2. You can either just draw a line if you're only like halfway down your page and put the title, or you can go to the next page. It is up to you how you want to organize. But this is 6.2, properties of rational exponents. Everything we are doing for the next 5 problems is exactly what we just did. We are applying all of the rules that you have learned. And this is going to be a lot like shooting a free throw. Here's what I mean. If I were to go down and shoot a free throw right now, I would probably miss, because I do not do it very often. But if you put one of these problems in front of me, I can do it every time, because I've done it like a billion times. These problems are going to seem hard and overwhelming to start, but we need to practice, practice, practice. Here we go. Are you ready? Remember when we were expanding things on the board? Like writing y over x, remember all that? Okay, we're going to do that on this. It's a little warm-up to get us ready. So, bear with me. You can do it. All of this is being raised to what power? The second power. Which means I could rewrite this as all of this times another one of all of this, right? Just like x squared is x and x, this whole thing squared is going to be this times another one of this. Right? That makes sense. So we're going to write, because we're going to slowly expand it out and cancel things out. So this is the same as y to the third over 8y squared times another one of them. Y to the third over 8y squared. Bear with me? Good so far? Those are the same thing. That whole yellow thing squared is the same as multiplying it by itself twice, yeah? Okay, let's keep going. How could I rewrite this y to the third? How many y's is that? So how many y's are there total on the top? So I'm going to just draw 6 y's. 6 y's. Y to the third, that's y. On the bottom, how many 8's are there total? I'm being tricky. Just 2, right? It looks like it shares that 2, but it doesn't. It's just an 8. So there are 2 8's. 8 and another 8. How many y's are there total, though? Now there's 2 in each, but 4 total, right? And from here, do you remember what we did? If there are 4 y's on the bottom, if I cancel 4 on the bottom, I get to cancel 4 on the top. So what is left on the top? 2 y's, but we don't write 2y, we write y to the second. And on the bottom, we have 8 times 8, which is just 64. And that's how we did these problems. Done, right? We expanded it out, wrote it out, and then canceled things out until we got like a nice simple form, right? Remember doing these on the boards? Okay, so now I'm going to go to the next problem. And this is why we have to have the rules we just talked about. Because it's going to be very difficult to do this exactly. So I'm going to go to the next slide. Is that okay? Okay, now look at this example. What's the issue? If I want to, if I have y to the third, it's y, right? How do you write y to the 3/4? Right? You can't, can you? You can't really write, what am I going to do? Write 3/4 of a y? Doesn't really work, does it? And that is why we have these rules. Because when they are fractions, we kind of need a rule to help us out. We're going to be doing the same thing. We're just going to be dealing with fractions instead. And I know, we love fractions. World runs on fractions. And what we need to do is we are going to apply our 5 rules. And it is hard to know which ones to use when this is your first time doing it. It is your first time. You are not going to be good at it. that's okay. Like I said, if I went down to throw a free throw right now, I have not done that in probably like 2 years. I would miss. I would probably miss. But I've done a billion of these. I could do these all day long. Okay, so this is like your first free throw you've ever thrown in your life. Remember, you were really tiny and you probably airballed it in like 2nd grade gym. It's probably bad. Right? That's what's about to happen. Just prepare. You're about to airball. It's okay. When I am doing these problems, the first thing I always like to do is I do not want parentheses in my problem. If I can get rid of parentheses, it makes everything easy. So I have all of this raised to the power of 2/3. If you look at that tiny little sheet of paper that has your 5 rules, one of them looks like this. You have to find it. Which one is a fraction raised to a power? Power of a quotient. And what do we do with the power when it's a power of a quotient raised to a power? What do you do with that power, that red power I highlighted? We just did it. You literally just did it with a lot. What do you do? Who gets this? Everything, yes. Everything gets the power. It's like distributing. So if I look at the top, we got to give y to the 3/4. We got to give it a 2/3. On the bottom, I have to give everything 2/3. I have to give it to the 8, and I have to give it to the y. See how I'm giving it to everything? Spread the love. Everything gets it. That is one of the rules, is give it to everything. We're not going to worry about adding or subtracting or multiplying anything. We're just going to give everything that exponent first. So the top is going to become y to the 3/4, which it already was, but now it's raised to the 2/3. We gave the top another power. So now it's a power to a power. We'll just leave it like that for now. On the bottom, I'm giving both things the 2/3 power. So now I have 8 to the 2/3, and y to the -1/2 is now also raised to the 2/3. Can you see how everything got the 2/3? Literally everything, right? When you have a bunch of stuff inside parentheses raised to a power, you can get rid of those parentheses by giving everything on the inside parentheses. Whether it's a fraction or not, everything gets it. Yeah? That makes sense? That was one of our laws. Now, what's nice about these problems is you can pretty much just go crazy. Any rule you see, you can use. So, I focus one part at a time. I just make it easy on myself. For now, I'm going to ignore the bottom. The bottom doesn't exist to me right now. I'm only looking at the top. Look in your laws. What happens when it looks like that on top? Which law is it? It is a power of a power, right? It's a power raised to another power. Whenever you see this, whenever it looks like this, no matter what the numbers or fractions are, a power to a power, what do? What do you do with your exponents? And if the fractions disturb you, just think of an example that isn't one. If I had x to the 2nd to the 3rd, what happens? What does this become? Remember? You multiply. This becomes x to the 6th. All we did was 2 times 3. Even though they're fractions, you do the same thing. So we are going to multiply what? 3/4 and 2/3. So you take your calculator out and you multiply your fractions. Multiply. What is it? 0.5, which is 1/2. Y to the 1/2. That's the new top. Wait, so you multiply both of those? 3/4 times 1/2. Multiply power to a power, and multiply it for your exponents. It just sucks that they're gross, nasty fractions. It is what it is. The world we live in is not all whole numbers, sadly. It's mostly gross, nasty decimals. On the bottom, okay, 8 to the 2/3. Those are just all numbers. Is there a variable in this? No. We just put it in our calculator. What is 8 to the power 2/3? You just put it in your calculator. It should just be 4. Okay, 8 to the 2/3 should give you 4. It's just when it's just all a number, you can just put it in your calculator. The variables we can't do in our calculator because they're literally unknowns. We don't know what the number is. But if we have something where we know all the numbers, you can just plug it in. So all we're left with, one piece we kind of have left right here. What is this? This is a power 2a, which means what do I do with my exponents? Multiply them. Negative 1/2 times 2/3. You get it? Not negative 2/9. Well, I guess technically, yeah. It simplifies to negative 1/3. You just have to click math, enter, enter, and it turns it into a fraction. See? Yep. Yep, negative 1/3. Okay, so look at the nonsense we started with, and look at where we are. A lot better. One more thing we can do. One more thing. It's like a puzzle, isn't it? These are like puzzles. What? You can't. You need to. Okay, I'm gonna write it. I'm gonna write something on the board. Are you ready? Forget the problem for a second. Erase from your mind. What does this become? Y to the 3rd, right? Because this is 5y's, this is 2y's, and you do what with the exponents? You subtract them. This is, do you see that over here? Where is that happening over here? You see? These are, your eyes, you need to have math eyes. These look the same to me. Do they look the same to you? Someday they should. Look, when I look here, I go, oh, 5 minus 2, 3, y to the 3rd. When I'm over here, I see the same thing. I go, oh, look, a y and a y on the bottom. Y on the top, y on the bottom. They have exponents. I got to subtract them. Remember when we are dividing two things with the same base, we need to subtract our exponents. But again, we don't love fractions. I wish we did. 5 minus 3 is easy to do in our head. 1/2 minus negative 1/3 isn't as easy. So subtract those in your calculator. Subtract them now. Yeah. We're doomed to do fractions by hand for all eternity. You gotta be prepared for what happens if you get to those pearly white gates and they're like, add these fractions or you're not allowed in. Could happen, we don't know. Math enter, enter. Math enter, enter. We want a fraction. Yes. 5, 6. This minus negative 1/3. And it should be 5, 6. Y, these two became y to the 5/6. Did that 4 on the bottom go anywhere? No, it's still there. We can't forget about it. It's like your dog. You don't just leave it at the park. It's still there. Oh, because they aren't doing the alpha thing, so they get a decimal. They have to turn it into a fraction at the end, but when you use the alpha thing, it keeps it a fraction. You just keep doing it your way. Yep. Okay, so what has happened? Many things have happened. We applied many of our rules. This is like you guys right here, right? Your life's a little bit of a mess right now. Yeah? Right? A little messy. This is like me. Straight chilling. Simplified, baby. Now we go next. What do you mean? I have many. I have many for you. Example 2. Go again. Again, you basically, that was your first free throw, right? You airballed it. Hopefully this time you can at least hit the rim. What is 2/5 times the quantity x to the 1/2 y all to the power 4/5? Write it down now. Okay. Who can remember what I said? What do I personally like to do first? You remember? I do not like parentheses, so I try to use a rule that helps me get rid of parentheses. So I go look at my parentheses and I look at what's on the inside of them. On the inside of my parentheses, I see an x to the 1/2 times y. On the outside, I see an exponent of 4/5. What can I do with the 4/5 power? I heard it, but you whispered it. When you have many things raised to a power, what do we do with the power? Share the love. Everything's going to get what? Yes, distribute. Everything gets a 4/5 power, but only everything in the parentheses. See that y to the 2/5? Not part of the party. He doesn't get one. See how I only gave it to what was on the inside, but I need to give it to both things. You can't just give it to one and not the other. That's not fair. So, after this, we still have y to the 2/5. That did not change. We didn't do anything to it. Times x to the 1/2. Now it's also raised to the 4/5 because it got another power. Times a y to the 4/5. Oh, now look how much better it looks. Much better. Ish? Better? Cleaner? What you do next? You do. You do you. What you do next? What you got? What do we do next? Tell me the rule. Look. What? No subtracting. I see no division. What will I do? Are there no... Which rule do you see? I see a rule that uses addition, yes, and I see one other rule. What is the other one we can do? Look at your rules. Do you not see a power to a power? Is this a power to a power? Power to a power, yes? Stare at this. Look. Do you see it? Look. Now look with your eyes. See it? Look at it. Hey! Look at it. See it? This is a power to a power. Look. Stare. This will show up so many times. It will always look like this. Always. Power to a power. Look at it. Power, 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 power. Do you see the powers right next to each other? Power, power? Do you see it? Power to a power. What do you do with a power to a power? Say it. Say it again. Power to a power means multiply. Power, power. Do you see? Do you see the power to a power? Because if I go to the next problem, which has a power to a power, and you do not say power to a power multiply, I give up. We all drop a letter grade. We, yes. I'll call my high school and be like, bump it down, bump it down. Power to a power, multiply it. Okay, that means you take your calculator and multiply 1/2 and 4/5 together. Do it. Do it now. There's about 20 spots in that pit waiting for you guys. We learn to multiply practice. Math ed director, I do not want a gross nasty decimal. Alright, x to the 2/5. Okay, bring everything else down. Okay, here we are. We're here. We're chilling. Bye. Now we turn to Tyler, because I know he knows what to do because he shouted it out earlier, hopefully. What? Yes! Which two things can we put together? Who are best buddies in this problem? Are these not best buddies? Same variable, and they're being multiplied, which means we do what with the exponents? We add them. If you are sitting there with your mouth open like, duh, watch. At some point in this class, we had something that looked like this. X squared times x to the 3rd. What do you do with the exponents? Add them. How many x's are here? How many x's are here? How many x's are all together? What did we do? We added the exponents. 2 plus 3 is 5. Here, what are we going to do with the exponents? Add them. So add them now. The exponents, yes, because they both have a base of y, we can add them together. X is a loser, no friends, doesn't get to add with anything. It is what it is. Some of you are X's, you know. I'm a Y. Yes, you should get 6/5. X squared, drop him down. He wishes he could be part of the party, but he ain't. Done. Perfect answer. You did it. Bumped the rim. Still didn't make the free throw, but we're getting closer. Yes, yes you will. You can do it. Are we ready to go next? You don't even want to know about the topics we've already skipped. Alright, go next. Example 3, write it down. Woo! Write it. Write it now. Five simple rules. See? You'll never get there unless you... What? Am I who?
Were you good at this in high school?
After I practiced, yes. I'm going to help this much. Can you see, Tyler, how much I'm going to help you? Can you see how much I'm going to help? I know you can't see that far. What am I gonna do first? Now don't talk and make the rest find out. What will I do first? What will we do first? What will you do first? Pick the rule. What are you going to do? What do you see? What's happening in the problem? Look. Yes. What are we distributing? The 5, 6 is going what? Everywhere. Everywhere. Watch. Watch. Watch, watch, watch. Look. Everyone gets a 5, 6. Everyone gets the 5, 6. 64 gets a 5, 6. A to the 4/5 also gets a 5, 6. Everyone got a 5, 6. It's like Oprah. Look under your chair. You get a 5, 6. You get a 5, 6. You get a 5, 6. Essentially, this is the law of Oprah. Everyone gets the exponent. I'm really trying to help you remember it. All right. Most important question of the day. Are you ready? Tyler, don't say it. What am I going to do next? What am I going to do next? There are powers in the problem. Yes. What am I going to do next? Do you see the power to a power? Where's the power to a power? Power to a power means we do what? Multiply. So do it. Do that. Go do it. I'm above this. I don't have to do it. You do it.
Teaches you how to think, bud.
What do we get? Okay, there's one more thing I can simplify. What can I do? Say it. There's something I can still put in. Come on. Yes, you're right. Don't say it. What else can I do? Now, what do I do? Something here I'm allowed to put in the calculator. What am I allowed to put in? Yes, this is all just a number, so we should find out if that number can be put in our calculator and written down. It is 32. 32, a to the 2/3, and that's a wrap. Done. With example 3, so I have example 4. You thought?
How many more do we have?
Many. I just added one for asking that question. Now there are 6 examples. Anyone else? Yep, now there are 7. Anyone else? 8, 9. I can make these up all day long. Here we go. Write it down. Example 4. This is an origami class, that's why.
So like, how come like we didn't get like a second number for actual
All I heard was, why didn't I get more? I want more. Give me 2 notebooks. Where? It's not like you can go to the dollar store and get one for like 50 cents. You want a practice notebook? Go buy one.
That keeps everything more organized.
Here's the nice thing is that you can look at your notes now.
I was gonna say it's less to carry, so it's okay.
Yeah.
I was just wondering.
Pick your pencils up. Why they aren't? Get that in your hand. Put that in your grabber. Why is your pencils down? You're supposed to be doing things. Go. Ready to go. I think you're good, yeah? We're good? You're done. Come on.
You started.
Your life ends if you don't get this one right. No, you're starting it. I'm done. GG's. I'm good. I feel good. I'm fine. Go. Keep going. Stop. Do it. Come on. Gotta write it down. Start doing the problem. Go. Start doing. Do something. Do that. Right there. Do it. Start doing. Example. Come on. Do a law. There's just do some rules and get the answer. Go. Why are you not writing? Write. Write and do. Start doing. What are you doing? Pick a rule and do. I suggest giving the 7/8 to thing. Give the 7/8. Oprah that ish on the top. Do it. Oprah. Yes. Yeah. Give it to. You get a 7/8. You get a 7/8.
I'll take a picture.
Oh, you failed the test. Yep. You did nothing yet. How can you learn if you've done nothing? You try and then I'll tell you. Try a rule. See if it works. If it doesn't work, try another. Yes? You were in the nurse half the period. This is a you thing. You problem.
Well,
Yeah. I tried to stop you.
well, I don't think that.
How did I offend you? There were no offense. No, I'm stating a fact. You're based on a decision that you made. I'm just stating history. It happened. When you drop an egg, what happens to it? What happens to it? It crashes. Action, time, reaction. You chose to go to the nurse, which made you miss half the lesson, resulted in you now knowing